Environmental impacts with fossil fuels. Okay, so the obvious is the production of greenhouse gas emissions, carbon dioxide, etc. Carbon dioxide in particular from the combustion itself. Okay, remembering that we still produce carbon dioxide when we burn biofuels, just the difference being that there's no net increase to atmospheric carbon dioxide. Whereas, obviously, our fossil fuels, we do have a net increase of carbon dioxide. But we also have impurities, like in our coal, etc., such as sulfur, right? And so sulfur is that yellowy sort of colour. When burned in the presence of oxygen, we produce sulfur dioxide, okay, which really stinks. Sulfur dioxide continues to burn or react with oxygen in the atmosphere to produce sulfur trioxide. Sulfur trioxide reacts with the water in the atmosphere to produce sulfuric acid, and we get acid rain. Same thing with nitrous oxides. So any nitrous oxides continue to react to give us nitrous dioxide that then reacts with water to give us nitric acid. Same thing with carbon dioxide. Carbon dioxide reacts with water to give us carbonic acid. So three main constituents for the possibility of acid rain to be produced. Thermal pollution of waterways caused by cooling water from coal-fired power plants, causing reduction in dissolved CO2 and O2 in water that destroys aquatic life. Okay, so other things as well. Air pollution, right? Depletion of the ozone layer, enhanced greenhouse effect, right? Remember, the greenhouse effect itself is important for the sustaining of life. Phytochemical smog and acid rain. Let's have a look at those forward. Greenhouse effect versus the enhanced greenhouse effect. Greenhouse effect is simply the natural earth warming, right? Otherwise, overnight, our temperatures would plummet to negative 20 degrees or something like that, and during the day would be like more than 50 degrees or something. The problem is the increased effect. So as we increase the amount of greenhouse gas emissions, water, carbon dioxide, methane, chlorofluorocarbons, etc., we are trapping more of that heat. Trap more of the heat contributes to net increase in global warming. So it's something like we've had, whatever it is, over 300 consecutive months of greater than average temperature compared to the last 120 years on record. So, yeah. So, obviously don't need to know this, but it just gives us an understanding of the mass produced per unit of these different fuels in which we're using. Petrol, LPG, natural gas, and coal. Coal, significantly high. Makes sense, right? Because coal is predominantly carbon. Yeah, so burn carbon in the presence of oxygen, you get carbon dioxide. Natural gas, you also get water as a byproduct. So it makes sense that you get lower amounts of CO2 per megajoule of energy produced. Right, natural gas, right, in terms of amount of CO2 produced per energy is better than coal. Other emissions, talked about sulfur dioxide, nitrous oxide, and ozone. So we talk about the ozone layer, right? The ozone layer is what, 20, 30 kilometers up, something like that, in the atmosphere. And we talk about it as, it's really like a blanket, right? It's a higher concentration of ozone at that location. Ozone, part of its role is that that helps us with life is that it traps harmful ultraviolet radiation before it reaching Earth, before it reaching the surface of the Earth. So by depleting that, we're allowing greater amounts of ultraviolet radiation, which is why, here's a fun fact for you, in Australia, we have more skin cancer than the rest of the world combined. So something to consider. And that's not per capita, that is total numbers. So our country of 25 million people has more skin cancer than the other 7.5 billion people on the planet. Right? We are near the hole in the ozone layer. We get large amounts of ultraviolet radiation, and we just love the sun. Yeah. So whereas ozone at lower altitudes, right, lower atmosphere, is harmful. We get photochemical smog, right? So ozone reacts with reacts with light. We can see a little bit of smog in our city today. Actually, it's pretty good today. Yeah, looking out there.
Well, we need to know.
No, right? Just more generally speaking. Particulates, right? Ash, whatever, irritants, etc. Carbon monoxide, we will look in greater detail, in particular when we explore equilibrium and we look at carbon monoxide poisoning and its effect on hemoglobin. Organic chemicals, methanal and ethanal, right? It's the only time when spelling really matters in chemistry is in the naming of compounds. Acid rain, mentioned that, right? So sulfur and nitrous oxides do help to produce acid rain. Okay, you've got a A3 sheet of paper on your tables, right? It's about 1 between 2, maybe 1 between 3. There's an extra one here that's not being used. And what I want you to do is draw up this table and have a go at completing it in your small groups, right? Okay. All right, here we go. Here's a. See how I go. Moving that up there. Okay, coal, right, 32 kilojoules per gram, roughly. Right, 30 to 40% efficiency. Renewability, obviously, it's not, despite having extensive resources. Crude oil, yeah, about 48 kilojoules per gram. Octane has a 25% efficiency in petrol engines, and we've got limited resources of our oil. Yep, this is all part of the presentation. It's on the next slide. Petroleum gas, right, slightly higher, so like LPG, again, not renewable. So pretty much all our fossil fuels are not renewable. Coal seam gas, right, similar to petroleum gas or natural gas. Gas is stored in mixture of water and coal deposits anyway. Again, limited resources. So sourcing is from fracking, fracturing of rock coal beds to release the gas. Obviously, all of our other environmental concerns there that we explored, right? Toxic chemicals, issues with waterways, and so on. Petroleum gas, we source it from distillation by cracking larger hydrocarbons. Crude oil mixture of alkanes split into fractions again through distillation, mined at land or sea. Coal, open cut mining, long-term impacts. Huge news. It was, like, I don't know if it's still huge news, but a couple of years ago, the Adani mine. Anyone know about that? Yeah. What's some of the issues there? Right, it's an enormous open cut mine that has irreparable damage to the environment. Yeah. The environment surrounding the mine cannot recover ever. So it's real issues. Right, all of our combustion issues with fossil fuels, yeah, net atmospheric increase of CO2, enhanced greenhouse effect, and then other impurities like sulfur toxins present. Biofuels, right, biogas, largely methane, so about 50 to 60% of about 56 kilojoules per gram. When do we use kilojoules per gram versus kilojoules per mole? I think I mentioned this. Why do we use one over the other? When would we use kilojoules per gram versus kilojoules per mole? Any thoughts on that? Right? You're allowed to be wrong. It's not an exam. It's not going to affect your study score if you have a go at answering. We can measure in mass. When can we measure something in mole? Yeah. But when can we for a substance? Right. If it's pure, right, so if it's 100% that compound, we can use mole. We can't use mole if it's not a pure compound. That's what it comes down to. So anything, right, anything that is a mixture, right, or an unknown definitive chemical formula, we're going to use kilojoules per